What's up, guys? This is a series pertaining to the mathematical angle of socionics, and it's just a bit of I will be going through some rudimentary mathematics pertaining to socionics. Now, socionics is it's more of a field, but it consists of psychological taxonomies, mostly typologies that initiated Osra Augustino Vucci initiated through Carl Jung's work on psychological types, and it was also derived from Antoni Kapinski's theory of information metabolism. So this is some of I'll be going through the structure because it'd be cool to get some of the formal pieces pertaining to socionics and how the pieces fit into the puzzle structurally, and I'll be going through some of the operations, and I'll be going through, let's say, dichotomies, maybe models and groups, and other things that make the cogs turn. And it might be a little dense, so if you're still here to learn about the mathematical aspect of socionics, and yeah, this might be a good playlist. So in this video we're going to start off with dichotomy, the notion of dichotomy addition, which employs XOR logic, which is exclusive OR, and it operates of the both or neither principle in simple terms, and it works with Boolean logic, which is why it's often used in computer science. And there's also the notion of dichotomy multiplication using XNOR or XAND logic, where basically the base vector is 1 and a flip is 0, like an on state and an off state. But in this video I will be using XOR logic, where 0 kind of denotes the sameness of a trait and 1 denotes a flip, for instance. So you can think of it as like a form of subtraction, almost. So many people who are into typology for a while, especially like Jungian or post-Jungian typologies, will know of the four Jungian the linear Jungian basis, which is basically it comprises of the four dichotomies or axes like proposed by Carl Jung. So extroversion, introversion, we have intuitive sensory, we have logic, ethics, and we have irrational, rational. For historical conventions, I will be using the ENTP code, which is just the ILE. It is historically treated as a basis vector, so for utility's sake, I will be continuing using that convention. And yeah, let's get through this. So dichotomies have properties in mathematics, where you have where you divide a set into two like mutually distinct subsets that comprise the test, so they're kind of distributive, they're complementary, these are bounded, and these two the subsets here, E0 and E1, are complements of a Boolean lattice. So this you can partition dichotomy into subsets where the subsets are complements each other. So whatever's in E0 is not in E1 and vice versa. So as we said near the start of the video, E0 or 0 represents kind of the base axis. So if we're treating extroversion as kind of the base vector, we're going to treat E0 as denoting extroversion and E1 as a flip of that trait. So E1 is introversion. So now we can the formula for XOR logic with dichotomies goes as this. So let's say we have dichotomy is D and E, right? So one dichotomy is D and another is E. So how this works, and then you get maybe another dichotomy F, but you have like D0 plus E0 or D1 E1 is more like the intersection actually. Over and this is the and that's going to be where the complement is. So you have D1 E0 and D0 and E1. Bear with my handwriting. So I would say that's just basic formula of dichotomy addition, but don't worry about it too much anyway. So now we will be going back to the adding dichotomies together. Okay. So let's say we're interested in, hold on, okay. This is N0 and N1, okay. We're interested in adding E and N, like, so extroversion, introversion, and intuitive sensing, where XOR logic, remember, if there's anything to take away from this video, is that XOR logic, even XNOR logic, operates off the both or neither principle. So that's something to take away from this video. So now what we can do is make a two-dimensional vector space, but an easier representation would be something like a Punnett square, where you basically have E0, we can represent this with an E, and then we can represent this with an I, and N0 and NS, N1 would be N or S. So now we have E and N, the conjugate would be E and N, would be E0 and N0, E0 intersected with N0, so we get En, we'd get In, and then we'd get Es, and then we'd get Is here. So now with XOR, you take the diagonals, so what's both En and what's neither En, so Is, and that would be our that'd be our third dichotomy. It'd be a derived dichotomy. So, and then it'll just like the complement of this dichotomy, this trait would be In and Es. So what we've done is we basically formed a two-dimensional vector space. So let's say we have the first vector, the x-axis would be extroversion, introversion, and we have intuitive sensing on the y-axis, so they can be denoted as Boolean codes. So it's a two-dimensional vector space over F2. Now F2 just simply means like a field of two elements, so which means you only have two options, 0 or 1. So we have 0, 0 means that it's both extroverted and intuitive. We have the vector 0, 1, which just means that this is flipped, so it's just ES, and then we'd have IN here, and we'd have both neither E nor N, so we have IS, so we have 1, 1. So now what XOR logic does is basically take 0, 0 and 1, 1, and that's your trait, and your complement would be 0, 1 and 1, 0. So we can extend this to the rest of the dichotomies. So I want to make this smaller actually. Let's just now we have, let's say, extroversion, intuitive, and logic, and irrational, and now we have, let's say, en. We can denote that with en, which is kind of the operation of XORing e and n, which is just Boolean code. And what Reinin called it when he initially was doing the operations is carefree, which is en or is, versus farsighted. And now let's continue this, shall we? Just so we can get the hang of it. So extroversion and logic, right? So we can draw the same Punnett square. We have E or I on the x-axis, and we have T or F on the y-axis. So we have ET, we have EF, and we have IT, and we have IF. So now we want to take ET and IF, and we want to kind of cancel the rest. Reinin calls this yielding obstinate. And now we have the temperament tetrachotamy, or the vector space. So how we can form temperament is by intersecting extroversion, introversion with rational, irrational. So if let's just make another Punnett square actually. EI and PJ, and we have EP, we have IP, we have EJ here, and we have IJ here. So now EP and IJ, that's static. To take, remember in this like setup, you take the diagonals, and then IP, IJ, EJ, that'll be dynamic. And then we have NP and TP. You can do this yourself if you want as an exercise, but this will just correspond to tactical and strategic, and this would correspond to constructivist versus emotivist. Construct, there we are. Now, since this is 4-dimensional vector space, you're going to get up to order 4. Oh, I missed NT. I missed NT. So you can take the club actually, if you want to get the club tetrachotamy, which is where you have your researchers, you have your socials, you have your aristocratic clubs like your sons are just kind of like the NFs, and you have your STs or pragmatists, NFs idealists. Okay, there we go. For NT, we have ST, and we have NF, and we have SF here. So now, what's this called? This is called democratic aristocratic. So we can write dem or arist. Now, okay, so let's just get rid of all this again. Just an alarm. Alright. I'm gonna get rid of all of this actually. We don't need it here. we have a linear basis. So now we'll continue this. So what you can do is like you can derive a truth table. There might be truth tables in the link, in the description. But what I could just do is a shortcut where you can just take some other derived dichotomies. Let's say we want to use NT, which is just dem arist. Most people that are into socionics for a while kind of know about democratic and aristocratic, so we'll use that. So let's say we want to find out what ENT is. Now, the both or neither principle still applies, so it's not just this or that or that. It's one or two, so we can just take this or that, like both this and that, or neither this or that, or you can just go the other way, we can just use NT and E, or neither NT or E. So we're going to use this for simplicity's sake, people like know it about it. So intersection, we have democratic, and we have aristocratic, and we have E, and we have I here, so extroversion, introversion. So what is, so the extroverted Democrats would be the extroverted alphas and extroverted gammas, so they'll be AE or gamma extroverts, like that. And aristocratics, so that'd be BE maybe, and delta E, and this would be okay, this would just be that. And aristocratics, introverted aristocrats would be a beta introvert and delta introvert, like that. So we take the diagonals as before, and so what is so introverted aristocrats and extroverted Democrats, we actually get positivism and negativism. I'm gonna write plus or minus just to keep it simple, and then we can carry on this. There's just only 4 here, so that's just ENT, and we have NTP, just put it there, and we have ETP, and we have ENP as well. That's interesting for people, especially people who like quadra, like want to know where the quadra dichotomies come from. So they're third order dichotomies. So we can have like let's use yielding for this one. And no, let's use, actually, yeah, let's do this. So let's use constructivist and extroversion, and let's use extroversion and tactical. So we have extroversion on the y-axis, and on the x-axis we have tactical, strategic. So we pretty much have tactical corresponds to inert intuition or contact sensing. So you think of the extroverts that have contact sensing. So they would be the extroverted judicious types. We'll find out judicious means someone who values any or si. So think of, actually I'll write it like this again. I'll use alpha extrovert and delta extrovert. We have extroversion and strategic, so that corresponds to beta extrovert and gamma extroverts, and we have introvert tactical, we have beta introverts and gamma introverts, and we have alpha introverts, and we have delta introverts. So the common denominator here that they're alpha or delta. So, and this would be judicious decisive. Now you try to do this one as constructivist and emotivist, which have contact logic. You get the merry extroverts here and the merry introverts here, and this will just be the no, there's the serious, so like delta and gamma types here. So this will just be merry serious. And you can use Demarest and P&J. I can spare you, but it's just process result. And now we have the fourth order dichotomy, which is TP and EN. Or you can just use that, I guess, as your vectors. Or you can use NT and EP, that might be easier, because it's just static dynamic and democratic aristocratic. You just get asking, declaring. So hopefully this helped you out. It's a bit disorganized, I know. So, but I hope this helped out. Take it easy.